All
right, we're
how do you
recording.
want us to put all the data just on like an Excel sheet?
Yeah, that would be fine. So this is kind of weird because normally, you know what I do is I let you guys present your data in class. I guess I could still do that. We'll see. But yeah, normally you'll put together a PowerPoint. Now in your PowerPoint, I don't need to see all your data, all your calculate. Well, I need to have enough information in your PowerPoint that I can reproduce whatever your numbers are, so I can see if you made a mistake. But I don't need to see the raw data itself. Does that make sense?
So you want it on Excel and a PowerPoint?
So normally in class, what I want is a PowerPoint. I don't care about Excel. But I do want to see all, so if you're doing a hypothesis test, I want to see all the steps and I want to see all the numbers used. So your N equals, your standard deviation, your means that you used, all that kind of stuff. But I don't need to see the raw data. But yeah, so I should be able, based on whatever's on your slide, like if you go through the 8 steps on your slide, that's great. And I should be able to get the same number as you got on yours, so I can check your math and make sure you got it right, or see if you got it wrong.
You probably told us before, but when is this due?
That's a good question. I've got my calendar here. I think let's shoot for April 21st, and then I think I'm going to make this a review day because we've got 3 groups. We should be able to. You could spend 20, 40, 60 minutes. We'd still have some time left over because there's only 3 groups, right? So yeah, let's bake that. I think at this point we're probably going to be good here. So yeah, here's kind of my calendar. We're going to finish up chapter 18. We'll probably start on 20 today. We'll finish 20 on Thursday. We'll do 21 next week and 22. Then we'll do chapter 25, and then we're going to jump back to chapter 6. I don't know why they made that. These 2 chapters really go together. And then we'll do your projects on Tuesday, and we can do a review on Thursday, and then our final exam. Luckily, I'm not going to be here at 7 a.m. I'll probably just make it available all day. I'm still trying to figure out how the tests work. But yeah, probably our final exam will be on Tuesday the 28th. And then we'll go from there. So then the semester will be over. So.
Well, thank you. And one more question. Would you be able to give like a sample like PowerPoint to put on? And it doesn't have to be like the same one, but just so like we can know how to format our PowerPoint. Is that okay? Because it's different questions, so we're not gonna like have the same answers, but just so that we can know how exactly you want it to be formatted. Or you can make one up.
I'd have to go back. I've actually been doing this same project for a few semesters now. Well, I guess it's not. No, it'll be a little different. I could maybe do that because we're asking a different question. Yeah.
Because that would be really helpful.
Okay. I'll see what I can do on that.
Okay, thank you.
The problem is finding a good one because I will just warn you. There are a lot of people who make mistakes on this, even in a group setting. So, but I'll try to find one that is well formatted, even if the answers are wrong. I'll probably have to take off the title page so we don't know who it was. But yeah, I'll see what I can do on that.
Okay, thank you so much.
Mm-hmm. All right, so let's finish up with chapter 18 and we will have your homework due on Thursday for, oh, this is the wrong chapter 18. We'll have your homework, or is it? Yeah, this is the wrong one. We'll have your homework due for chapter 18 on Thursday. All right, just 1 second while I find this. Okay, let me start sharing.
I have a quick question. All
Okay.
the lecture notes that you show us, do you just add it? Where do you add those to at the end of class?
Oh, that's a good question.
Didn't.
Normally, if you go to assignments, if I go all the way to the bottom, I've got lecture notes under worksheets from class.
So you'll just add each of them to there?
Yeah, and so, yeah, I've got all the stuff from chapter 17 right there.
Okay, thanks.
And so I'll add chapter 18 after today's lecture.
Thanks.
Okay? All right. This doesn't look like the right stuff. Okay. Okay, let's do, did we do this one before? I don't know if we did. Okay, let's just review really quick. Chapter 18, hypothesis test for mean, standard deviation is known. Okay, so, well, this actually leads into chapter 20. So I'm gonna, I think I have the same thing in 18 and 20. So rules for hypothesis test for means, we'll just review this really quickly. Sample must come from a simple random sample. It must be independent. The data should be normally distributed with no outliers. We can use smaller samples, but a histogram or a QQ plot needs to verify the sample is normally distributed. I haven't showed you guys how to make a QQ plot, but yeah, you can get away with smaller samples if it says we are normally distributed. Okay. First question you should ask yourself is, do I know the population standard deviation? Okay. If the answer is yes, let me make this a little bit bigger because I think this is a little bit small. If the answer is yes, you're going to use the z equation, which is x bar minus mu over sigma over the square root of n. Okay, and notice it's got a mu sub 0 here because that represents your null hypothesis. If the answer is no, and we're going to cover chapter 20 today, we're going to talk about the T-distribution, so this is a good introduction to it. If the answer is no, you're going to use a T-distribution. The formulas are almost identical. It still says x bar minus mu. The difference is with z, you're going to use the population standard deviation, and with t, you're going to use your sample standard deviation divided by the square root of n. Okay, so in both cases, you need to be able to distinguish, do I know the population standard deviation? If it's yes, you use the z, and if it's no, you use the t, and we'll show you how to do that a little bit later. Okay. Now, did we do this example of the mean SAT scores in 2007 was 515? Or does this look like a new question to you?
We've done SAT scores before, but I don't think we've used these numbers.
Okay, so I think we did. Okay, we'll go through this one fairly quickly. I thought there was another one that I hadn't done yet. Okay, so the mean SAT scores in 2007 was 515 with a standard deviation of 114. Yeah, I think we did this one. Educational psychologist believes 4 years of English helps students better on math. Psychologist contains a simple random sample of 40 high school students with 4 years, finds their SAT math score is 540. Using alpha as 0.05, find out if the psychologist's beliefs are correct. So the first thing we do is we find all the values, okay? The mean score in 2007 was 515, so that's going to be mu equals 515. Standard deviation is 114, that's a population standard deviation. So we go sigma is 114. We got a random sample of 40 high school students. Your N is 40. Finds their mean math score is 540. 540 is your X bar. And your alpha is 0.05. Okay. So this is not categorical. This is quantitative. I don't know why that put that there. Okay. Your null hypothesis, mu is 515 versus mu is greater than 515. Everybody agreeing with that so far?
Yes.
Okay.
Can you move your thing up, the paper?
Like this?
Yes, thank you.
Okay. Okay, so so we need to find the test statistics. So there's 3 test statistics that I'm going to be doing. We're going to do the z-test, the t-test, the chi-square test. Okay. In this case, we know it's a z-score because we know the population standard deviation. So we're going to use a z-score. Okay, so we'll plug it in. We're going to get a z-score of 1.39. So we need to find the p-value. Oh, this comes into the question. I think Rachel asked it before we started recording today, but hopefully I'll answer it. So the question is, how do you know when to double your p-value? Okay. So we need to find the p-value. So we need to know whether I double it. So does anybody know if I need to double my p-value on this case? And
You
why?
do not need.
Okay,
Sorry.
you do not need to double it. Go ahead. And why?
I think you only double it if it's an equal sign with a slash through it, because that's like a two-tailed test.
Correct.
That's all I know.
So since this is so my alternative is a one-sided test, it's mu is greater than 515, so I do not have to double it. Does that make sense, Rachel?
Yes, thank you.
Okay. So whether you double it or not, all depends on your alternative hypothesis. Okay. Since we're doing a right-tailed test, I'm going to look up 1.39 on my chart. I should get 0.9177. I need to subtract that from 1 since it's on the right side, and I get 0.0823. Okay, so we're going to compare with our alpha of 0.05. We do not reject because 0.08 is greater than 0.05, so we do not reject. Okay, and so therefore, there is not enough evidence that 4 years of English helps your math scores.
So really quick, just to review. If it's equal sign with a slash through it, you double it. If it's a right-tailed, then you subtract the p-value from 1. And if it's left-tailed, the p-value is just what the p-value is.
That is correct.
Okay, thanks.
Okay. All right, so this is the one that we haven't done. So that was a quick review of our last lecture, okay? So this time, I'm going to make sure we're going to do these steps here. CDC says that the mean value of all cigarettes smoked per day is 18.1. We obtain a random sample of 40 retired smokers to see if they smoke less than CDC numbers. The data results in a mean of 16.8 cigarettes per day with a standard deviation of 4.7. Oh. Okay. Use alpha equals 0.10. Find out if retired smokers smoke less. So how would we do this one?
We should write out all the information we have.
Find out all the values. Okay, so CDC says the mean cigarettes smoked per day by smokers is 18.1. What is 18.1?
Mu.
Mu. Very good. Why is it mu?
Because it's from the population.
From the
not
population.
from
We assume that the CDC knows what they're talking about. Okay, especially with the coronavirus. right? We obtain a random sample of 40 retired smokers. What is 40?
Good number.
So n equals 40. Okay. The data results in a mean of 16.8 cigarettes. So what is 16.8?
X bar.
X bar, because it comes from our sample. Our standard deviation is, actually, I shouldn't say standard deviation because that's vague. Something is 4.7.
Sample standard deviation.
Sample standard deviation. Okay. And then we've got our alpha is 0.10. Okay. So that's our step number 1. Okay. Now, what's step number 2?
We find the null hypothesis. I shouldn't answer. I don't know.
You see if it's quantitative or categorical.
Quantitative or categorical? And our answer is
Quantitative.
quantitative. Okay. Question number 3. Do you guys remember?
I feel like now we do the null and alternative hypothesis.
That's correct. Find the null and the alternative. And so the null hypothesis is what do you guys think?
Well, it's either mu or population, and I'm not seeing anything to deal with population, so I'm going to say mu.
Okay, you said mu, but I didn't understand your reason. Say that again.
Well, we've only ever seen mu or population used, and population is only used when it's like a percentage, and there's no percentage in this, so therefore it must be mu.
You said population, but I think you meant proportion.
That is what I meant, my bad.
Okay. Yes, it is mu. It's mu because null hypothesis is always about the population, and so it's that number right there. So mu equals 18.1, right? Okay, let's pick on somebody like Jessica that I don't think you've spoken up today. Have you, Jessica?
No.
Okay, so what's the alternative hypothesis?
The alternative hypothesis would be mu is less than 18.1.
And why did you say less than?
Because they want to see if they smoke less than the average.
Yeah, I want to see if they smoke less. Perfect. Okay.
Can you scroll your screen down a little bit?
I have to be careful because I don't want to do that. Okay, I don't want to give away the answer, but yes, is that good? I guess if I keep this big gap here, I'll be okay. All right, so step number 4 is what?
Pick a
Grading.
test statistic.
Pick the test statistic, and we have 3 choices: the z, the t, and the chi-square. And so I guess I did give away. All right, so what do you guys think?
T.
It's going to be a t-test because why?
Because we don't have a population standard deviation, but we have a sample standard deviation.
We don't have the population standard deviation. Okay. All right. So this is a bad question because I was supposed to do another z-test, and I thought this was, but it is a t-test, okay? So do you know the formula for the t-test on your formula sheet?
X bar minus mu
X bar minus mu
divided by sample standard deviation divided by square root of n.
S over the square root of n. Okay, perfect. Now, I was thinking this was supposed to be a z-test, and that's why I saved it, but it's kind of good. This is actually, even though it says question 18, this is actually going to be a good example of a t-test, and so I'll teach you a little bit more about the t. But so let's figure out our t-score equals, and then this is where I have to scroll down a little bit. So here, maybe, can I make it a little bit smaller? Would that help? And then you can still see the numbers.
Yeah, that's good.
Okay. So X bar is, in this case,
16.8.
16.8 minus mu, and mu in this case is
Mu is 18.1.
0.1. We're going to divide that by S, and S in this case is
4.7.
0.7, and we're going to divide that by the square root of
40.
Okay. So now I can theoretically plug this into my calculator or spreadsheet, and I'm going to use a spreadsheet. And so it doesn't like that minus sign. Let's try this again. That gives me a t-score of negative 1.75. Okay. Now in this case, okay, so my t-score, t equals negative 1.75. Okay, so now in this case, the next step is find what?
P-value.
P-value, okay? All right, so now I need to teach you a little bit about the T-distribution. I think I have that in my notes that I was going to plan here. I just got this a little bit sooner than I expected, okay? So just like the z-score, your sample must come from a simple random sample. It must be independent. Data should be normally distributed with no outliers. Oh, that's funny. I was going to do this exact same problem first. Now, as far as the T-distribution here, let's talk, and I know that I'm off the bottom of the page. Let's talk about the T-distribution. Okay. Now, just like I'll call these A, B, and C. So, A, it is symmetric and looks like the normal distribution with, and I'm going to call it fatter tails. Okay. Now, it has something called degrees of freedom equals your sample size minus 1. Okay. And why that becomes important is the shape changes based on your degrees of freedom. Okay. It was discovered by a guy named William Gossett. He actually worked for a beer company, and he called it the student T distribution. And so let me see if I can show you a quick thing here. I know okay, this is a BYU Idaho's thing. They've got this really cool thing called the T-Distribution Applet. Now, one of the nice things is, wonder if well, this is kind of nice. Normally, this is BYU Idaho's thing, but you can kind of see the difference if I put this on here. The normal distribution, you can see that there's more. It looks a lot like the T-distribution. The normal distributions is a little bit thinner on the bottom. The T-distribution is a little bit fatter on the tails. And so as your degrees of freedom gets bigger, you can see that your T-distribution, once you get to about 30, they're almost identical. So your T-distribution on, let's say, 1 degree of freedom, you can see that there's a big gap between the normal distribution. And then as your degrees of freedom gets larger and larger, you can see that it keeps getting closer. And eventually, once you get to about 30, those are pretty close. Now they're almost, once you get up to 60 or 100, you can't even tell the difference between the normal distribution and the T-distribution, okay? So that's kind of a good example of the relationship between the T-distribution and the Z-distribution. So once again, it's centered. So the mean is 0. But you can see, especially for small distributions, in our case, we're going to go 39. So it's going to be pretty similar to the normal distribution. But in our book, we've got here, let me show you this. Where is my... So in the back of your book, you've got, and I've got it here as well. Let me make this bigger. What happened to my Zoom? There used to be a Zoom thing. Is that normally I used to hit Control Plus? That doesn't work anymore. Okay, so this is your student distribution. Once again, the you've got your degrees of freedom in this first column, column C. You've got your p-values across the top. Okay, so this table actually I think is a little bit better than the one in the back of your book. But the idea here is when you're finding your p-value, if you're using the table, you can't actually get a value. So in our case, let's go back to our case that we were working on here. Okay, so all right, so we're trying to find the p-value. Okay, we've got 2 methods. One is the computer, and you're going to find that the computer is actually easier than the table. Okay, with the computer, and I believe this is on, maybe I should pull up my formula sheet. Okay, so you are welcome to use your formula sheet on all tests and quizzes. You've got your there's your T equation right here. Oh, it's not gonna let me hide it. There it is, right there. Okay, that's your T equation there. You also have your Excel commands are here. So you've got T-Dist, which is a left-tailed test, right-tailed, and you've got two-tailed. Okay, so those are your Excel commands. And then you've also got your table here. I think it's a little easier to see, but there's your table. Okay, so you're welcome to use this. Okay, so as we look at this with the computer command, okay, I'm back to here. The computer command, because my alternative hypothesis here is a left-tailed test, I can use the command t.dist, and if you don't specify anything, it's a left-tailed test, and you're going to put in this case, your t-score, comma, your degrees of freedom. Okay, and so if I'm doing this on Excel, okay, I can say equals t.dist. Actually, let me copy this formula here for a second. Okay, so I've got my formula here. So I've got a t value of negative 1.745. So I'm going to do t.dist. This is going to be a left-tailed test, so I'm just going to pick this here, and I'm going to put in my t-score, my degrees of freedom. If my n is 40, what are my degrees of freedom?
$39.
39 degrees of freedom. And for cumulative, you always want to use the cumulative distribution. Now, this is a good place to say, what is the cumulative distribution? We talked about that about a month ago. Most people have forgotten what it is by now. Does anybody know what the cumulative distribution is?
It's like when you add them one by one.
Oh, very good. So if you have, yeah, so you're adding all of the probabilities. Now notice here, by the way, I should just mention, this is shaded to the right. If we use our normal distribution, normal tells us what's to the left. One of the nice things about the T-distribution is it is symmetric, okay? So at any rate, so I got a value of negative 1.74. My p-value is simply 0.044, okay? Now, so if I'm doing this with the computer, okay, in this case, my p-value is going to be 0.044. Now the table is actually a little bit harder to use, but I do want to show you how to do this. I will probably on the next quiz, I will have you use both the table and the computer because I want you to be able to know both methods. Now, the problem is with this table here, so we want to go down to 39 degrees of freedom. So we're on this line here, okay? Now the idea here is the table, all you can do is you can bracket your things. We got a value of negative 1.74. T equals negative 1.745, I think it was. Okay. So what we're going to do is now I'm going to ignore the negative for a moment, okay? Because this is symmetric, I can do that. I'm on 39 degrees of freedom and I'm looking for where does 1.74 fit on this line. So you can see that 1.74 is in between those two values, okay? And so therefore the answer for your p-value is going to be in between those two values. So all you can say in this case is your p-value is in between, I'm on 39 degrees of freedom. Yeah, so it's going to be in between 0.025 and 0.05. And so so the table is actually a little bit harder to use, but I do want you to know how to use it. Basically, you can see in here as I'm looking at these two values here, your p-value is between 1.685 and 2.023. Therefore, your p-value is going to be in between 0.025 and 0.05. So does that make sense?
Yeah, but what if your degree of freedom is bigger than 50? Because then it goes by tens.
Yeah, so then you can start rounding to the nearest. So for example, if your degrees of freedom was 44, I would probably round to 40. If it was 45, I would round to 50.
Okay.
So if it was 75, I'd probably round that to 80, and I would use those two numbers there. Okay.
Can you
And I've
do it?
actually, I think I've got more degrees of freedom than the back of your book. If you look at the back of your book, I don't know. Oh, you guys don't have a book, do you? Or do you have a book?
I have a book, but I use it as a coaster.
If you have a book, it's on page, where is it? Yeah, it's on page 699 of your book. You'll notice they only go up to 30, they don't go up to 40. So my table's a little bit better. And yeah, my table's way better than the book. So at any rate, you've got your formula sheet here. This is what I'm going to expect you to use for tests and quizzes. And I think you'll all agree that the computer is actually way easier because I can figure it out, and I'll do it again here. Equals t.dist. It's going to be a left-tailed test, so I'm going to pick that one. And I'm going to put in negative 1.745. Degrees of freedom is 39. Cumulative, you always say yes on this. Okay. And so 0.044 is in between 0.025 and 0.05. Okay. Now, the question is for Rachel, do I need to double this?
No, because it's symmetric.
No is correct. The reason that you said was wrong. It is symmetric, though.
It's not an inequality.
Yeah, it's because of my alternative hypothesis. I'm doing a left-tailed test.
So even if
Well, it
it's
is an inequality.
a t-test, you might need to double it.
Yeah, so if my alternative hypothesis, H sub 1 was P does not equal 18.1, now that would be a two-tailed test.
So what would you would just take that?
Well, I was just going to ask you, what would you do in that case?
Would you just find the normal p-value and then double it, so that 0.04?
Yeah, so we could take that and multiply it by 2, and that would be 0.088. Okay, now if we're using the table, we have to do the same thing. We've got to multiply, because notice, by the way, 0.08 is not in between 0.025 and 0.05. So now I need to double this, and so the 0.025 is now 0.05 doubled, and 0.05 doubled is 0.10. So your p-value is between 0.05 and 0.10, and 0.08 is in between both of those. Okay. Now, conversely, if you want to just double it automatically, the problem is t.dist two-tailed. You can do a two-tailed test. Now, the problem is it does not like negative numbers. Negative 1.745. Your degrees of freedom is still 39, and you'll notice that you'll get an error message. Okay. Now, the reason why that is because the two-tailed test expects that this is always a positive number. So if you just change that to a positive number, then it works just fine, and you'll notice that those two values are identical. Okay. So just remember, and I don't think that's on my formula sheet. When you go back to here, you can do a two-tailed test, but the 2t requires your t-score to be positive.
Can you show one more time how you got that 0.0443? Just
with the Excel command.
Yeah.
So equals t.dist, and I'm going to use the top one because it's left-tailed. Okay. And so then my x is going to be negative 1.745. They should call that t, not x. I don't know who designed that. Your degrees of freedom is what?
39.
39. And do I put true or false here? Always true. Okay.
Why do you put true?
So it goes back to, you want the sum of all probabilities to the left.
Okay.
So basically what it's asking you is, at this point, do I want to use the cumulative distribution? And yes, you do. You want the sum of all probabilities to the left of negative 1.74.
So are we pretty much always going to be doing true then? When would we
On a
do-
left-tailed test. Now the interesting thing is if you do a right-tailed test, t.dist right-tailed test, negative 1.745 degrees of freedom 39. It doesn't ask you on the right-tailed test, and it doesn't ask you on the two-tailed test. It only asks you on the left-tailed test. I don't really know why that is. But if I did a right-tailed test, that would be about, so you've got 4% to the left, you've got 96% to the right. Does that make sense?
Yeah. So on left-tailed tests, we'll pretty much always do true, or is there an example?
Yes.
Do false.
You'll always do true.
Okay.
Okay. So, all right. So let's go back to here. Okay, we got two methods. So the computer is there. If we use in the table, we would say it's between 0.025 less than p-value less than 0.05. Okay. All right. So now we're on to, so we just found our p-value. Step number 6 is reject or do not reject.
Rick, sorry, one more thing really quick. So
Okay.
for the table, would we not give like a 0.0443 answer? We would just give the p-value is between this and this.
Yeah. Yeah, that's correct. So so using the table, your p-value is going to be in between 0.025 and 0.05.
Okay, thanks.
Okay. This is really hard because I don't know. I want you to know both methods, so I want to test both methods. If we were still meeting together as a class, I would give you a paper quiz on Thursday, and I would say use this table. And then on the test, I would say use the Excel commands. I think I'm still going to go with that rule because I still want to make sure you know both methods. So probably on the next quiz, I'll probably say use the table for the p-value or use Excel for the p-value. Okay. All right. So based on, now let's go back here because we're scrolling off the page now. So I've got an alpha of 0.10. Okay. So if my alpha is 0.10 and my p-value is, didn't mean to do that. P-value is 0.044, or you could also, well, here, I'll do it this way, 0.044, or I could also say my p-value is in between 0.025 less than p-value less than 0.05. In either case, you should be able to decide whether to reject or not reject. So what do you guys think? I'm going to ask, is Carter here? I don't remember who's here. Carter is here. Carter, what do you think?
You do not reject.
Do not reject. Who agrees with Carter? Do you agree, Tori?
I don't know, because 0.04 is less than 0.1.
And so what does that mean?
Oh, is it low reject the hoe?
Yeah, so the rule is if the p-value is low, reject the null. So so are you sticking with your answer?
No,
No. So therefore,
you could do reject.
reject the null. Okay. Now I know step 6 is one of the hardest ones. Hopefully we can get that right, especially for our project. Okay. By the way, I should ask, who have you guys got all your data? Here, I'll ask Carter. Carter, is your group, have you collected all your data yet?
No, sir.
No, sir, that was the wrong answer. How about, are you in Tori's group, Tori?
No.
You're not?
We also haven't collected all our data.
Okay. How about Corinne's group? Is Corinne here? Are you in Corinne's group, Carter?
Yeah.
Oh, so yeah, that's the same group. So you haven't collected all. Who's the other group? Who am I thinking of? Jessica, are you in Tori's group?
She is.
She is. Okay. Well, whoever the other group is, Samantha. Is Samantha here?
Sorry, my mic wouldn't unmute, but yeah, I'm in Tori's group.
Okay. So whoever it is, so you really should have this done, because at this point, you really should be working on calculations. So please get this done as soon as possible so you guys aren't pushing at the end. Okay? All right. So we've rejected the null. So therefore, find the conclusion. I think I missed one, or I combined steps. What's the conclusion?
Is it not enough evidence?
Okay, this is what we're supposed to find out. Find out if retired smokers smoke less. So how do we answer that question? So here I'm going to write it out. There is, and I'm going to put / not enough evidence that retired smokers smoke less. So is it there is evidence or there is not evidence? What should be the answer here? I really wish I had a quiz poll question. Here, we're going to pick on somebody else here. How about Waverly? Haven't talked to you for a long time. Is it there is evidence or there is not evidence? And Waverly, if you're answering, you must be on mute. Are you here, Waverly?
I am here.
Okay, what do you think?
Can you hear me?
I can now.
Okay. Sorry, I can't see what's going on, but you do there is evidence because there is just is that right?
There is evidence because why?
Because it's statistically significant. It's below
Yes.
the why can't I? The alpha.
That below the alpha, perfect. That is correct. Correct answer. So well done, Waverly. Now, one way to remember this is there. If you say if you do not reject, then there is not. And maybe I'll put the not. The not goes with the not. Do not reject equals there is not enough evidence. And if you reject, then there is evidence. Does that make sense?
What is that word that you don't like us to say when we're talking about the conclusion and rejecting?
So words I don't want to hear. Words I don't want in the conclusion. Okay? There's the A word, except. That's horrible. Reject is another word I don't want to hear. I don't want to hear hypothesis. I think that's about it. Those are the three basic words. Don't want to hear anything about the hypothesis. Don't want to hear reject. Don't want to hear accept. Or maybe null. I don't want to hear it. Null goes with hypothesis. So.
Why don't you like those words?
Basically because prior to this class, if I talked about rejecting the null or accepting the null or anything like that. So accept is a bad word for a different reason, but you guys didn't even know what this would mean prior to learning hypothesis testing. And the idea here is we want to write the conclusion so that a non-statistician can understand what you're talking about. So a non-statistician doesn't understand a hypothesis, doesn't know what a null hypothesis is. Rejecting the null, they don't know what that means. Now, accepting, a lot of times people say, so we either reject or we do not reject. We never accept that the null is true or accept that the alternative is true. And the reason why, this comes back to kind of a statisticians are weird kind of a thing. And so that is, let's go back to the coin flip problem, okay? If I flip a coin and I get 7 heads, you might want to accuse me of cheating, but you might be wrong. So you would say there is evidence that you're cheating, or there is not enough evidence that you're cheating, but I don't accept that you're cheating, because accept is just too strong of a word. Then, so it's just really a reject or do not reject. That's what we want to stick with. We never want to accept that the null is true or accept that the alternative is true. And it's just because statisticians are weird and anal. That's kind of the main thing. Okay. So I just refer to that as, that's another one of the A words. So accept is an A word. It's like a swear word. So we don't say it in statistics. Okay. All right. So any other questions on that? I know we're about out of time. Okay, so here's what I would like to do. So mainly, the funny thing is, I was thinking that we were gonna, well, that's funny because I actually, my chapter 20 notes was the exact same problem. I didn't realize I had actually included that with my chapter 18. So that was a mistake on my part. But how are you guys feeling on Z-scores and T-scores? Do you feel like you can identify the difference?
Yeah, for the most part.
Okay. All right, well, here's what I'm going to do. So chapter 18 is going to be due on Thursday. I think I do want to spend a little bit more time on 20, but as we do these, I want to be able to make sure you guys are really good at distinguishing between a t-score and a z-score. And so I think what I'm going to do is I'm going to kind of quiz you guys. So chapter, let's think about this. We did chapter 17. That was the quiz that we did today. So chapter 18 quiz is going to be on Thursday. Chapter 20 quiz is going to be on a week from today. So I think it would be good for you to get started on chapter 20, but 18 is all that's going to be due on Thursday. Does that make sense? I kind of feel like we're almost good on this. I just want to make sure. I know this is one of the hard things, is picking between the Z and the T. So I think I want to spend one more day. So on Thursday, we're going to make sure that you can understand the difference between the Z and the T. So we'll spend one more day on this, and then we'll move on to something else. Does that sound good?
So to pick between the Z and the T, isn't it just if you have the population standard deviation, or if you have
That is the main question right there, yes. And it's also quantitative. Okay. Now, as a reminder, have I taught you the proportion test yet? No, I guess that'll be next week. I will just mention this as a parting shot. If it's categorical, it's always going to be a z-test, and I don't care if I know the population standard deviation because it's categorical and I can figure it out myself. Okay, so that's your clue for next week. Okay, this is always quantitative. Okay. Alrighty then. Well, I'm going to let you guys go, and the quiz on chapter 18 is due on Thursday.
Thanks, Rick.
Thank you.
Yep, we'll see you later.